and welcome to another Common Core Geometry video by eMathInstruction. My name is Kirk Weiler, and today we'll be doing Unit number 9, Lesson number 11 on constructing tangents. So, today we're going to be looking at the last constructions we'll do in this course. And they're not overly challenging in terms of step 1, step 2, step 3, but they are things that need you to understand about the relationships that tangents have with circles, and one relationship very important in general. So let's start by looking at that. All right. Maybe the most important fact about tangents is in exercise number 1. So let's take a look. Exercise number 1. Line M is tangent to circle A at point B. What is special about the relationship between line M and segment B? So what is it? Here I've got, segment AB, which is a radius, and tangent line M. What is the special relationship between M and AB? Pause the video now and see if you can remember. All right, well, it's this simple. M is perpendicular, whoops, oh, it should have been that simple. M is perpendicular to AB. Tangents are always perpendicular to the radius at the point of tangency. This will always be a 90-degree angle. In fact, anything that has a 90-degree angle to a radius must be a tangent. All right? That actually kind of goes back to Euclid's parallel postulate and things like that. But the plain fact is, if I've got a radius and I've got a line that is perpendicular to it, all right, at that point on the circle, then that's a tangent. Likewise, if it's a tangent, then it's perpendicular to that line. All right? And this is one of the more amazing things in circle geometry, right? It simply doesn't matter how or where that tangent is drawn in particular, there will always be that 90-degree angle, right? No matter where I've got it on the circle, the tangent line is always perpendicular to that radius. All right? That, along with some construction work that we've seen before, is going to allow us to do two different constructions of tangent lines in today's lesson. So let's review some basic constructions before we get into the ones with the tangent lines. All right, exercise number 2. Let me read it through for you. Review the following constructions. Letter A. Construct the perpendicular bisector of AB shown below. Using this construction, label the midpoint of AB as M. All right, well, this is a construction that you've seen many, many times. So what I'd like you to do is pause the video now and see if you can remember how to construct the perpendicular bisector of segment AB. All right, let's go through it. So remember how we do this. We take our handy dandy compass. We stretch it out so that it's more than half the length of AB. That's important. Okay, and then what we do is we draw an arc above the circle, and what most students will do is they'll just sweep that arc right there below the circle, and that's fine. All right, then without changing the radius, we're going to do exactly the same thing but from point B. All right, now the reason that we're doing this, recall, is so that we locate 2 points, one up here and one down here, that are equidistant from the endpoints of the line segments. And because they are, they must lie on the perpendicular bisector. So what we can now do is we can connect those 2 points with our straight edge, which thankfully I can make a little bit longer. All right, and that will then create the perpendicular bisector of AB. It'll also allow me to find the midpoint, or point M. Now you probably already can understand why this is going to be an important construction, because quite frankly, tangents are all about perpendicularity with the radius. All right? So obviously the perpendicular bisector could have something to do with that. Let's take a look though at a more complicated construction in letter B. Letter B says, construct a segment perpendicular to line M shown below that passes through point A. So obviously, in the first construction, we constructed a line that was perpendicular to this line, but it specifically went through the midpoint M. In the case of letter B, what we want is we want to construct a perpendicular line to M that is guaranteed to pass through A. This is a construction we haven't done nearly as much as this one, but we have done it before. Pause the video now and see if you can remember how to do this, and then we'll review it. All right, let's go through the construction. So the construction in letter B actually hinges on the construction in letter A. But the first step is that you put your compass so that the center of your circle or arc is at point A, all right, like that. And then you can either draw a full circle or just draw an arc right there, and then with the same radius, draw an arc right there. What you're really doing is you're constructing a segment that goes between those two intersection points that has A as its midpoint. And now what we're going to do is we're going to construct the perpendicular bisector of the segment that's got these two endpoints. And because it's the perpendicular bisector of that segment, it's got to pass through the midpoint, which is A. So we're going to do now the exact same construction we did in letter A, except now we need to extend that again so that it is more than half the length of that segment. All right, again, switch, keep that radius the same. All right, and now what we will see when we bring this over, if we've done it correctly, and we have, is that that line is now perpendicular to line M and passes through A. Again, what we're really doing with that initial kind of arcs, those two, is we're creating this segment that starts here, ends here, and has A as its midpoint, so that when we then construct the perpendicular bisector of that segment, it goes through the midpoint, it goes through A. All right, let me step back for a minute to have you look at this, because we're going to need this one especially in the first construction of a tangent. All right, let's do it. Here we go, exercise number 3. Using the construction from number 2b, construct a tangent to the circle C below at point A. So what I want is I now want some kind of tangent line, some line that comes in here and is tangent to the circle right at A. And remember, what you will get absolutely 0 credit for is bringing your ruler up and kind of doing this and going, all right, well, that's about right there it is, and then drawing it in. You won't get any kind of credit for that. So let's talk about how we're going to do this. Now remember, the key here is that that tangent line at A will be perpendicular to the radius CA. So what I'm going to actually do is I'm going to come in like this, and I'm going to draw a line that passes through C and A, all right, and extends for a little while. All right. Now what I'd like to do is I would like to draw a line that is perpendicular to CA and passes through A. That should sound identical to the construction that we did in 2b. All right, so I'm going to take my compass, put it at A, bring it out like this, make an arc like that. Uh-oh, I think that's going to be too long, Kirk. Oh, it is going to be too long. All right, let me erase that. Oh, I can't. I just have to do this. That's okay. There we go. Let me try it a little bit more. I could still have done that. I just, if I had extended the line more down here. Anyway, I'm going to bring this back a little bit. All right. That should be good enough. Okay, do like that. And now like this. Okay. We now have this segment that goes from here to here that has A as its midpoint. Now I'm going to do the perpendicular bisector of that segment. So I'll bring over my compass like this, widen it out so that it's more than half of that. Draw an arc like that. Switch the compass's point so that it's here. And bring my ruler over. And draw that perpendicular bisector in. Now what's really cool that you should already be able to see is that that thing is going to pretty closely go through A and be perpendicular to the circle. Or sorry, and be perpendicular to that radius, right? And that's the key. The key is that this tangent line that I constructed is perpendicular to radius CA or AC. So what I have to do is I have to use that construction that says, all right, I want to construct a line that is perpendicular to this line, right, but passes specifically through that point. Okay? So let me get out of the way after that false start and you can take a look at this one. All right. Now, the other type of tangent that we're going to construct is fairly easy, all right, but way more complicated to understand why it works, all right? But let me explain what we're going to be doing. The other type of construction we're going to do is we're going to take a circle and a point that is outside of the circle and construct a tangent from that outside point to the circle, all right? So again, the idea is I have some circle, all right, some point outside the circle, and I'm going to construct, actually there's going to be two of them. That's not a tangent down here, but this one's a little bit better drawn. I'm going to construct those two tangents, all right? And what I'm going to do in this next exercise is I'm going to walk you through sort of why the construction works before even showing you the construction, all right? I know that sounds a little bit weird, but sometimes I'm just a little bit weird. Okay, let me get rid of this, and let's take a look at exercise number 4. In the following diagram, circle C and circle B are drawn and intersect at point A and another point that's not labeled. Explain why, given circle B only, that angle PAC must be a right angle. So, again, I want you to concentrate on circle B only. Don't worry about circle C at all, just circle B. And I want you to explain why angle PAC, why this angle right here must be a right angle. Okay? Pause the video for a moment and think about why that is. All right. Well, this goes back to an earlier lesson in this unit, right? Thinking only about circle B, since PBC is a diameter, right? Then arc PC is a semicircle. And anytime you have an angle inscribed in a semicircle, that angle is a right angle, all right? So angle PAC is an inscribed angle that intersects a semicircle, or 180-degree arc, right? We know inscribed angles are always 1/2 of the measure of their intercepted arcs. And since arc PC is 180 degrees, angle PAC must be 90 degrees. Let's take a look at letter B. Explain why, given letter A and radius AC, PA must be tangent to circle C at A. So again, why does PA have to be tangent to circle C at point A? What would you write down for letter B? Well, it's as simple as this, right? Tangents are perpendicular to the radius at the point of tangency. So, since PA is perpendicular to CA, it must be a tangent. It must be a tangent. All right. Final, and this is important, letter C, what special point along PC is point B? Explain. It's pretty important. Now, B is the midpoint. B is the midpoint of PC, and that's because the center of a circle is always the midpoint of a diameter. Extend the page. All right, so let's go back, make sure you get this. Right? So we've got this diameter, PC. We know B is the center of the circle, and therefore it must be the midpoint of this. Now before we go on and we actually do the construction, let me make sure you get this. What we're going to be given is we're going to be given some circle, circle C, let's say. And P is going to be the exterior point that we want to draw a tangent to. All right? We won't know point A, not yet. The idea will be we'll connect the center of this circle with point P and we'll locate its midpoint. We know how to do that with a construction. That was exercise 2, letter A. All right, we'll find that midpoint. Then all we have to do is draw the circle in. That will be simple. And where this circle intersects with this one is going to be point A, and that will allow us to draw the tangent. Okay, and I'll review those steps, obviously, in the next problem. So, let's do it. All right, here we go. Exercise number 5. The diagram below shows circle A along with exterior points P and Q. For each exterior point, construct the 2 tangents from that point to circle A, leave all construction marks. All right, so here we go. Let me walk through it for point P. All right, this is kind of cool. So what we're going to do for this construction is we're going to take point P and we're going to draw a line between point P, or a line segment, I'm sorry, between point P and point A. All right, now, real quick, I'm just going to do a flashback. That's this line. That's PC. All right, except now it's PA, whatever. Okay? Now what I'm going to do is I'm going to locate the midpoint of that line segment by doing a construction. All right, we're going to do the midpoint construction, if you will. So what that forces me to do is to do the perpendicular bisector of this segment. All right, I've got to stretch my compass out so that it's more than half the length of that segment. Okay, I think that's more than half the length. Okay, I'm going to draw an arc like this. Okay, flip it around and draw another arc like this. Okay. And now I will connect them with my straight edge. Yep. And the interesting thing is I'm doing all of that simply to locate the midpoint of that segment, this guy. Again, flashback, that is the center of this circle. That's that guy, point B. Okay? Now, all I need to do is draw that second circle in, and that's actually quite easy to do because I know the center of the circle, and both point P and point A, both point P and point A are on the circle, like that. That's now this secondary circle here. Okay? Let me just move this out here, bring this up, and now my points of tangency, interestingly enough, are the intersection points of those two circles. So if I go like this, that will be one tangent line. Whoops. I really just didn't want to do that. And then this will be the other tangent line. Isn't that a fantastic construction? And think about all the different things that it entails, right? It really gets down, at the end of the day, it's really all about this diagram and the fact that we force a right angle to be in there because of this right triangle being inscribed in the semicircle, or that, let's say, inscribed angle intersecting that 180-degree arc. All right, there were a lot of steps in that construction, though, a lot of steps. See if you can do the construction of the two tangents that come from point Q. All right, take a little bit of time to do that. All right, let's go through them. I'm going to switch over to red. All right, that way, hopefully we're seeing everything in a slightly different color. Whoops. Didn't mean to do that, but let's bring this down. Now again, what we're going to start with is we're going to start by connecting the exterior point to the center of the circle, hopefully, with a line segment. That's a little bit better. We now need to construct the center of that line segment. All right, and we will do that by coming in here and finding the perpendicular bisector. All right, that looks like a perfectly good arc. And switch. Try to get that point a little bit better on there. Perpendicular bisector. Move this out of the way. Bring my ruler in. It's interesting, I feel, like we do all of this just to find the midpoint of that line segment that connects the center of the circle with the exterior point. All right. We now have the midpoint of that line segment. I now just have to draw in the circle that has that as its center, and a radius that I can get from either point A or from point Q. And then it becomes the intersection points of that circle with point Q that are my points of tangency. Come on. I slipped off a Q. And rotate a little bit. There's one tangent. And rotate again. Sorry, there's a couple different circles and lots of arcs. And there's my other one. Move that out of the way. Ooh, look at that. Cool. Point Q, tangent, tangent. Again, kind of a tricky construction because there's a lot going on here. You know, we've got our circle with center A. Let's just concentrate on point P, right? We connect A to P and we find its midpoint. That's probably the hardest part of this construction, is getting that midpoint by just doing the perpendicular bisector. Once we have that midpoint, we draw a circle with that as its center and a radius extending from there to either A or to P, it doesn't matter. And then where that circle, that new circle, intersects our original one, those 2 points are the points of tangency. All right? And that's it. Again, it's kind of a tricky construction, but it uses all the math, or much of the math, that we learned in this unit. All right, let's do a wrap up. So there are two primary constructions of tangents when it comes to circles. One of them is simply saying, construct a tangent at this particular point on a circle. To do that, you just extend the radius from the center of the circle through that point and outward from the circle, and then construct a perpendicular line that goes through that point on the circle and is perpendicular to that radius, that extended radius. The harder one is to take a point that lies on the exterior of a circle and draw or construct the two tangents from that point to the particular circle. To do that is a little bit too lengthy for me to summarize it all at once now. All right? But you can of course go back and review how we did it in those other two cases that we just did. All right, for now I'd like to thank you for joining me for another Common Core geometry video by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.